Hi everyone! In this video I'm going to show you how to solve systems of equations graphically. And we're going to do two examples in this video. The first one's going to be a linear system, and the second one is going to be a quadratic linear system. And for this video I'm just going to be showing a simple integer solutions. So the times when you'd actually want to use graphing are when you get nice integer solutions. If you're going to get ugly fractional or decimal stuff, you're probably going to want to use an analytical method or a graphing calculator to do all the hard work for you. Anyway, let's jump in and do a couple questions and you'll see how this works. So first of all, you need to remember your basic linear equation, y equals mx plus b. I'm assuming you know how to do this. If not, search for a YouTube video on graphing slope-intercept form. M is the slope, and b is your y-intercept. And so our first equation is already in this form. This green equation here is already in this form, so we can just go ahead and graph it. 5 on the end gives us our y-intercept of 5, and our slope of 2/5 means that we need to go 1, 2, 3, 4, 5 boxes over for the run, and 1, 2 boxes up for the rise. And so 5 over 2 up gives us our next point, which means working backwards, 1, 2, 3, 4, 5 back, and 2 down gives us our previous point. And then you can connect, sort of as best as you can, ideally with a straight edge, to get yourself your nice looking graph. Now our second equation isn't in this form, but thankfully we only have one step algebra to get it into this form. So we're going to get that y is negative 2x minus 7 in our standard slope-intercept form. So our y-intercept again is going to be at negative 7, and our slope is going to be negative 2, which means over 1 down 2. Which means if we go back 1, it's up 2. Back 1, up 2, back 1, up 2, right? It's the same slope, just in the reverse direction. And so if you continue that all the way across, you get yourself your second line. Okay, so we've graphed the two lines. Now, what does it mean to solve this system of equations? The solution to a system of equations is this point right here where the two lines cross. And so long as your lines aren't the same slope, you are always going to have on a plane one point of intersection between any two lines with different slopes. And this point here is the solution. And solutions are really fundamental to tons of different areas of math and practical applications. We aren't really going to get into the applications today in this video, but this point here is the point we care about. And so our solution then we can just write as that point. And so this here is negative 5 is our x value, and our y value is 3. So one thing to note about these equations are in two variables. We've got y and we've got x. We've got y and we've got x in both of our equations, which means we should get a y and an x in our final solution as well. And so there you have it. There is your solution to this linear system. Now let's do a simple quadratic linear system. So I've given you, in this question, a quadratic in standard form, and I've got a linear equation that's not in y equals mx plus b form, but it's, one step away. So let's graph our quadratic equation, and the usual way we're going to graph a quadratic in standard form is by completing the square. So to complete the square on this one, we're going to start by common factoring our negative sign out of our x's, which means it's going to be positive x squared. And if you take a negative out of the positive 4, it becomes negative 4x. And then we've got a negative 9 over here. Now we're going to need to add our terms to actually complete our square. So if you watch my completing the square video, you've probably heard me say quite a few times, this 4 term, we want to half it. So half of 4 is 2. Half it, square it, add it, and subtract it. So if you half, square, add and subtract 4, you get the plus 2 squared minus 2 squared, and then this negative 9 is just chilling outside. Now we can then complete the square for what we have inside of our square brackets here. So this is going to be x minus 2 squared, right? Minus because of the minus sign here and the 2 from here. And then this negative 2 squared is a negative 4. But don't forget about the negative sign in front. When you distribute that negative sign across your negative 4, it becomes plus 4. And then minus 9. So y is negative x minus 2 squared. And then positive 4 and negative 9 makes negative 5. So this we can graph. Negative 2 means that we're going to move to the right, remember, not the left, because essentially what you want is you want 2 minus 2 squared, right, is 0 squared. And then your negative 5 on the end means that your y is negative 5 when your x value is 2. So when your x value is 2, your y value is negative 5, and so there's your vertex at positive 2, negative 5. Now, because of this negative sign in front, our parabola shape is actually going to open down. So just a quick recap, if you've forgotten, our basic parabola shape, just your regular y equals x squared shape, is what you'd normally do from your vertex, which would be over 1 and then up 1 squared, which is 1, over 2, up 1, 2, 3, 4, because 2 squared is 4, right? So over 1, up 1 squared, over 2, up 2 squared, over 3, up 3 squared. And then you do your symmetrical points to that. So that would be your basic parabola shape. But because of the negative sign in front of this one, instead of opening up, we want to open down. So instead of going over 1, up 1, we're going to go over 1, down 1 squared, over 2, down 2 squared. And by symmetry, we have those points as well. And that already takes us to the edge of our graph, which should hopefully be enough space for our solution to this problem. So this equation in pink, we can just rearrange to be y equals negative x minus 5. So negative 5 right there gives us our y-intercept, and negative x is a slope of negative 1. So over 1, down 1, over 1, down 1, over 1, down 1, over 1, down 1. And sure enough, this goes exactly through 2 of the points on our parabola. So it goes through this point here and this point here. So let's label those. This point is 1 over and negative 6. And this other point over here is 4 over and negative 9. So the solutions to this system of equations, so a system is just a fancy word for multiple equations together. So our solutions are 1 comma negative 6 and 4 comma negative 9. All right, let's do one more example where they actually don't have two solutions. In this last example, we're going to get, well, you'll see, you're going to have less than 2 solutions. So just a quick reminder, if you're talking about quadratic linear systems, you can actually have 2 solutions is what we saw in the last example. But you could also have a line that goes exactly along the edge of your parabola, or you could have a line that just misses your parabola entirely. So you can either have, you guys remember from the discriminant of the quadratic formula, you can have 2, 1, or 0 solutions. Well, same thing graphically, of course. So let's look at this one, and I'll give you a hint. It's not going to be 2 solutions this time, but let's actually graph this. So the plus 5 for our linear equation, we're going to graph first. So 1, 2, 3, 4, 5. 5 up is the y-intercept of our linear equation, and a slope of 2 means over 1 up 2, over 1 up 2. And backwards is back 1 down 2, back 1 down 2, back 1 down 2, and so on. So there you have a quick sketch of your linear equation. For the sake of time, I gave this second one already in vertex form. So the plus 1 means our vertex is going to be 1 to the left, and the plus 2 means our vertex is going to be at 2. So our vertex is there, and it is opening down. So we are going to go over 1, down 1. Over 2, down 2 squared. Over 1 down 1, over 2 down 2 squared. And since we've got room, let's do over 3 down 2, 4, 6, 8, 9, right? Because 3 squared is 9, so over 3 and down 3 squared is 9. So there you have your nice, beautiful parabola shape. And as you can see, this linear quadratic system has one solution. And the solution is -2 on the x, and then 1 on the y. And, just since we're here, if our equation had instead been, I don't know, let's say it was y, our linear equation that is, let's say it was y equals half x plus 5, right? Then you would have had a line that looks something like this, which is above the parabola everywhere. So this one would have 0 solutions. Okay, and that's quadratic linear systems with nice integer values, which is most of what we care about for your understanding, at least.